As night falls, an old man points his homemade telescope at the starry sky, and the 4 moons of Jupiter are clearly visible in the lens. As if waving to him, this is Galileo Galilei, a giant in the history of modern science, known as the father of modern observational astronomy and father of modern physics. Unlike Leonardo da Vinci, who dabbled in a wide range of fields, or Newton, who constructed a complete system, he, with his telescope and experiments on the Leaning Tower, broke the authority shackles since Aristotle, laying the foundation of experiment and observation for modern science. From a teenager in Pisa to a prisoner of the Roman Catholic Church, Galileo told the story of humanity's persistent pursuit of truth with every observation, every formula, and every debate. Born in 1564 in a declining noble family in Pisa, Italy, Galileo's father was a musician and mathematician. In his childhood, Galileo showed a strong curiosity and practical ability, often disassembling the mechanical devices at home to explore their working principles. At the age of 17, he obeyed his father's order to study medicine at the University of Pisa, but developed a strong interest in mathematics and physics. He often skipped classes to attend mathematics lectures and taught himself the works of Euclid and Archimedes. In 1585, Galileo dropped out of school due to family poverty. After that, he worked as a mathematics teacher in Florence and other places, while conducting scientific research. In 1592, he was employed by the University of Padua as a professor of mathematics, where he spent the most brilliant period of his scientific research career. The University of Padua had a free academic atmosphere, providing a good environment for Galileo's research. During this period, he invented the thermometer, improved the telescope, and conducted a large number of mechanical experiments. In 1609, Galileo heard that the Dutch had invented an instrument that could magnify distant objects. He immediately started research and made a telescope according to optical principles, with a magnification of 33 times. This was the first telescope used for astronomical observation in human history. When he pointed this telescope at the sky, a new universe appeared before his eyes, and a series of major discoveries followed, completely changing humanity's understanding of the universe. Galileo first observed that the surface of the moon was not as flawless as Aristotle said, but full of mountains, valleys, and craters, similar to the surface of the Earth. This discovery broke the traditional concept of heaven is noble, and Earth is humble, proving that celestial bodies, like the Earth, are composed of matter. Subsequently, he observed that Jupiter had 4 moons orbiting it, which directly challenged the geocentric theory. According to the geocentric theory, all celestial bodies should orbit the Earth, while the existence of Jupiter's moons indicated that there were celestial systems in the universe that were not centered on the Earth. Galileo named these 4 moons the Medicean stars to curry favor with the Medici family, the rulers of Florence at that time, which also reflected his survival wisdom beyond scientific research. In addition, Galileo observed the existence of sunspots and found that the sun was also rotating. He observed the phases of Venus, which had waxing and waning like the moon. This phenomenon could only be explained by the heliocentric theory, providing strong evidence for Copernicus' heliocentric theory. He compiled these astronomical discoveries into a book called Sidereus, Nuncius Stare Messenger, which was published in 1610, causing a great sensation and making him famous, but also angering the church forces that adhered to the geocentric theory. Galileo's astronomical discoveries and support for Copernicus' heliocentric theory were strongly opposed by the church and conservative forces at that time. The church adhered to the geocentric theory, believing that the Earth was the center of the universe, which was consistent with the description in the Bible and regarded as an unshakable truth. Galileo's research results challenged the authority of the church, so he was accused of heresy. Galileo's scientific achievements are not only reflected in astronomical observations, but also in his establishment of modern scientific research methods. which have had a profound impact on fields such as physics and astronomy. In mechanics, through a large number of experiments, Galileo summed up the principle of inertia: an object will maintain a uniform straight line motion or a state of rest when not acted upon by an external force. This principle overthrew Aristotle's wrong view that force is the cause of maintaining the motion of an object, and became the basis of Newton's first law. He also studied freefall motion, concluding that freefall motion is a uniformly accelerated straight line motion, and gave relevant mathematical formulas. In addition, he studied projectile motion, finding that projectile motion can be decomposed into uniform straight line motion in the horizontal direction and free fall motion in the vertical direction, which is of great significance to military and engineering. In astronomy, Galileo's observational results provided strong support for the heliocentric theory, promoting the revolution in astronomy. The astronomical telescope he invented opened a new era of astronomical observation, enabling humanity to explore the universe more deeply. His observations of the Moon, Jupiter, the Sun, Venus, and other celestial bodies accumulated a large amount of astronomical data, providing valuable information for later astronomical research.